All right, Lancers, today we're going to learn about something called ray diagrams. We're going to make a bunch of drawings today, and what the purpose of these drawings is to predict where the image of an object that you put near a lens is actually going to show up, okay? So when you just have an object here with no lens, right? So say you were standing over here, light from the sun hits the object and then just goes right to your eyes. And the reason that you believe that the object is here is when anywhere you stand over here, the light will just come from the object and hit you in the eyes. And your eyes, you from experience, just assume that the light kind of follows a straight line back. Okay. So now with a lens, the lens is going to bend the light and going to fool our eyes, and make it look as though the object is actually somewhere else, and that's where the image of the object is going to be. So let's give this a go. And so what you want to do is you'll notice at the top of the page, and by the way, again, this is page 76. If you look up at the top, it says we're going to draw, up to 3 principal rays. One of them, it says it's drawn parallel to the optical axis, and then passes through or appears to come from the focal point. So let's just give this a try. I'm going to just kind of leave it here so you can still see these. So the first ray is going to come in parallel to this optical axis. So we're just going to draw this guy in like this. Now you want to try to do this carefully and neatly so that you really do come in parallel to the axis. So there we go. So there's this light ray coming into the lens. Now this light ray, if the lens weren't there, would just go straight on through. But because this is a diverging lens, the lens is going to diverge out. And the idea is, well, how do we know how far out to diverge the light ray? Okay. And the only way we can know is we have to be given a focal point, and it turns out we're given the focal points of the lens here. So this light ray, since this is a diverging lens, it's the type that's skinny in the middle, what it's going to do is it's going to diverge out as though it had come from this focal point. Okay, so that light ray is going to go tearing off like this. Okay, but it's not in just some rando direction. It's as though it had come straight from that focal point. So when you're lining this up, you got to get that part right. Okay, so there's one of the light rays. So a light ray would come in and then just kind of diverge away like that. The next ray, it says there's one that goes straight through the center of the lens. So here's the dead center of the lens. And let's draw that second light ray. And what we want to do is go right through the center like this. And what you notice is these two light rays, the light rays coming from the top of this thing, they're not going to meet each other, right? So these light rays are going to just diverge away. What happens is if you're standing over on this side of the lens, if this is, say, your eyeball, here, I'm going to draw eyeball in here. Here's your eyeball. You don't have to draw eyeballs in ray diagrams. But the idea is you would believe that because of this light ray hitting your eyeball, that the top of that arrow is somewhere along this line, right? Now, where this gets interesting is up here. If you kind of move up here, a light ray hitting your eyeball, you would believe that the light ray was the top of the arrow was somewhere along this line. So what ends up happening is from this light ray, you think, okay, the tip of the arrow must be somewhere along this line. From this light ray, you think, oh, the tip of the arrow must be somewhere along this line. And so what we got to do is kind of trace this guy back, because the light ray looks like it's coming from here, even though it didn't actually come from there, right? The lens kind of fakes us out. And what ends up happening is these two light rays appear to be coming from this point. Okay, and so this point is actually then where the tip of the arrow shows up. So this is your image. Okay, so this is called, well, I'll write it first and we can talk about it, but this is what's called an upright, for obvious reasons. It's the same orientation as the object, is an upright, and then what's called a virtual image. Right. Now, the reason this is what's called a virtual image is the light ray never actually went there, right? This light ray just appeared to be coming from there, right? So that's where the image would show up. And you notice it's a smaller upright virtual image. I'll show you like a real example of that later with a with a lens and an object. So that's our first, what's called ray diagram. Okay. Now that we've drawn those two light rays, right, that's where the image shows up. Now I'm going to draw another light ray right now. But the idea here is that we wouldn't have known, like, so from the top of this object, you actually, like I mentioned before, have like an infinite number of light rays that would come off. Okay, but we've picked these particular ones because they know where they're going to go. So only now that we have this image drawn in here, we know now that if you were to bring a light ray, say from the tip of this arrow, and it went here, okay, now how far up would that light ray bend? Well, it turns out we know now that the light ray would bend up as though it had come from the tip of this arrow. So it would end up bending up kind of like that. Okay, now this one, however, is not one of the principal rays. There's no way, if I had tried to start with this one, there's no way I would have known how far up to bend it. But I do now that we've used these kind of principal rays. So again, this was kind of principal ray 1, and this was principal ray 2. And then this third one I drew was just kind of a random one. Okay, turns out in this ray diagram, we can't use the a third ray that's mentioned here. Okay, so there's one example using a diverging lens with the object outside the focal point. You get this upright virtual image. So let's give another one a go. This one's interesting. This one is a different type of lens. This is what's called a converging lens. You notice it's fat in the middle. And what we're going to do is we're going to kind of start this the same way. The idea is to figure out where the image shows up. So you start again with this light ray that comes in parallel to the optic axis. So let's do that. Here it goes. Okay, now this is a converging lens. And if you, by the way, if you forget, you can always fall back on that marching band theory, right? Like in comes the light ray, right? If you were the bottom part of the row of marchers would kind of hit the slow material first, so the light ray is going to get kicked like this, and then you can see on the way out, this part of the marching band would hit the fast material first, so it would kick down even more. So the upshot is it's going to converge. And how do we know how far to converge it? Well, it's going to converge such that it goes through this focal point, right? That, in fact, that's how a focal point is defined. It's such that any light ray you bring in parallel to the optic axis is going to go through the focal point. So what's going to happen to that light ray is it's going to go just like this. Right, so there's your principal ray 1 coming in parallel to the optic axis. The second light ray, just like before, is one that goes through the center of the lens. And you can even see some of my faint remnants of a line there on the drawing. So in comes the light ray, goes straight through the lens. I'm going to need to move my straight edge. And what you notice is these light rays actually are going to cross. Okay, so they happen to cross right here. There's principal ray 2. So what this is saying is light rays from the tip of the arrow go through the lens, but then meet up again here. And so what that means is that your image, your tip of the arrow, is actually going to show up here. Right, so this, what we have now located here is an inverted, and then this is what's called a real image, because the light actually goes to that spot. Okay, and I'll show you later that this is what you get when you're actually trying to project an image onto a screen. The light actually goes there. So if you put a screen here, it will just show up. Okay. So 2 light rays are enough to actually locate the image. Don't forget to draw the whole thing. Sometimes kids will just see this point and they'll go, it's here. But what you need to do is actually show the bottom of the arrow too. So draw the whole thing. In this case, we can actually look at a third ray. And that third ray would be one that comes in through the focal point. Let me get this lined up just so. So here's our third ray coming down through the focal point. Right. Now this ray, how do I know where it's going to go? Well, you can probably guess, but the idea here, the trick you can use is any light ray path is always reversible. So for instance, this top ray we knew it was going to kick down through the focal point. So if you reverse the path of that top ray, that means if you come through the focal point and then the lens, then that means you got to come out parallel to the axis. So that's exactly what's happening here. This light ray is coming through the focal point, so it's got to come out parallel to the axis. Now what you'll see is, and this particularly if you were careful making your drawing, is that these light rays are all going to meet up at this spot. So there's our principal ray 3. Okay, so you have these light rays coming off the tip of this arrow. They go through the lens and then converge at this point. And so that's where you get this inverted real image. Now that we have this, I will show you again that there's actually an infinite number of light rays that come off the top of this. But we happen to pick these 3 because we knew where they were going to go. All right. But now that we know where they go, I could just pick some random light ray. All right. I'm going to pick one that goes down here. And again, I would not have started with this one because there's no way for me to know where it would go until I actually know where the image is. But now that we've done all this work, as it turns out, we actually do know now that that light ray would get refracted such that it goes right through that point. Okay, but again, there's no way you could have started with that because you wouldn't have known how hard to bend it. So the reason we started with the others, so this, I'm just going to put this one was a kind of a random ray. Okay, not one of the principal rays. Not one of the principal rays. Okay. So that is a ray diagram for a converging lens, at least with the object outside of the focal point. Right. So I'm about to turn you loose on trying a couple of these things without me. Okay. A couple things I want you to notice. All right. First of all, we can even start with this bottom one. Right. First light ray we drew came in, bent through the focal point because it's converging lens. Next one went right through the center. You notice those 2 light rays actually met on that side. Okay. That means the image is going to form there. On this top example, right, we brought a light ray in and it bent up, and then we brought one through the center of lens, and what you notice is those 2 light rays don't meet, right? And you're going to see that sometimes when you go to make ray diagrams, that, oh my gosh, those light rays aren't going to meet. But don't worry if they don't meet. That just means that there's not going to be an image on that side. What you'll do is you'll trace them back to see where they came from. Okay, so I'm trying to give you a heads up because you're going to take a couple give a couple of these a try without me. So what I want you guys to do and give it a try before going on to the next video, just use a pencil, just give it a try, is on page 77, which is really just the next page in your book. There's a couple opportunities for you to kind of practice this, okay? So here's one with the object outside the focal point of a converging lens. Hint, that is exactly the case we did, the second case we did. Here's an object outside the focal point of a diverging lens. As it turns out, that was actually the first example we did, but you can kind of repeat it here. And then there's 2 cases that you haven't seen yet. But I just want you to give it a shot using the skills that we've learned, and you may be able to get those bottom 2 by just trying to follow the pattern. And then in a upcoming video, if you really do get stuck, I can give you a little bit of help with that. All right, good luck. Give it a shot. Give those ones on page 77 a try with your straight edge and pencil. And again, the goal is to try to find where the image is located. By the way, there's a duplicate page of that in your book following this. This page I repeated for because it will be a good way to review for a quiz or exam later in the unit. But right now, just try to do one of them and get all 4 of these drawings. All right, give it a shot.